This video will show you how to make a change in mass histogram. The first thing I'd like to point out is that little triangle before the word mass. That's a symbol called delta, and that symbol just means change. So when you see delta mass, that's really telling you change in mass. The first thing I'd like you to remember is the purpose of a histogram. So we know that histograms group data together. All the data that could be the same goes into the same bin. And data could be the same because of any errors or uncertainties in our measurements. So when we made our mass histogram of pennies, we put all the data that could be the same due to the uncertainty or sensitivity of our balance. A histogram is also a great way to help us answer questions that we're asking in labs. So for example, this lab had us answer the question, what is the mass of a penny? And we put all of our data into this histogram. It was a great visual way to see that pennies have two distinct masses. A penny either has a mass of about 2.5 or about 3.1. It also really easily let us see that little outlier over here that didn't fit in with any of the other data. In Chapter 2, every single one of our labs is going to be asking, does the mass change? We're going to do things with matter, and we want to know at the end, does the mass change? So when we're actually making our histogram, we will be answering the question, did the mass change when we did this thing to our data, or to our matter? So in 2.1, we dissolved salt in water, and our question is, does the mass change? Now that we have all of our data, we can make a histogram to answer the question, did the mass change? There are three possible answers to this question, no matter what lab we're doing. The first answer is no, the mass didn't change. Another possible answer would be yes, the mass increased. If the mass increased, we gained mass or gained matter. We could also say that yes, the mass decreased. There was a loss in mass, or we lost matter. Please remember that when we are calculating the change in mass, so delta mass, remember that means change in mass, is after minus before. Another way to think about that would be final mass minus initial mass, or again, if we're calculating the change in mass, it's the mass at the end minus the mass at the beginning. So if our answer is no, there was no change in mass, our delta mass calculation would be 0 grams. If we had an increase in mass, our delta mass calculation would be a positive number. And if we lost mass or the mass decreased, our delta mass calculation would be a negative number. So when we are making our change in mass histograms, there will always be a 0 bin for our data. Remember, we're grouping data that could be the same together, and when we're making a histogram of changes in mass, we're trying to answer the question, did the mass change? So we want to make sure there's a bin for all of the no answers, because if we get a 0 gram change in mass, that's telling us that there was no change. So when we are setting up our x-axis, there will always be a bin for all of the changes that could be 0 grams, because that will tell us no, the mass did not change. This is a really easy way to know if no is the answer. We'll see a lot of data in our 0 bin. We also kind of usually want our 0 bin to be in the center of our histogram, because if we have a gain in mass, that data will be to the right of our 0 bin. If we have a loss in mass, that data will be to the left of our 0 bin. Anytime you make a histogram, the size of the bin is based on the uncertainty of the measurements. So when we were making histograms of masses, our bin sizes were plus or minus 0.01, which is a total size of 0.02 grams. But those were single measurements. Our change in mass calculation is based on two measurements. So our bin size is based on uncertainty, but this time it's our final mass minus our initial mass. The final mass measurement had an uncertainty of plus or minus 0.01 grams. That's the uncertainty of the balance. Same for our initial mass. It had an uncertainty of plus or minus 0.01 grams, which means our change in mass, that calculation has double the uncertainty because it was made with two measurements. Our change in mass uncertainty is plus or minus 0.02 grams. That means when we find our calculated change in mass, it could be off by plus or minus 0.02 grams because each of the two measurements used to make that calculation could be off by plus or minus 0.01 grams. So for a quick mathematical example, if my final mass was 10 grams, I know that could be off by plus or minus 0.01 grams. If my initial mass was 5 grams, I know that could also be off by plus or minus 0.01 grams. So how do I get the plus or minus 0.02 grams? Well, let's say that my 10 grams was really 10.01 and my 5 grams is really 4.99 grams. So if I do that math, I end up with 5.02 grams, which is 0.02 grams away from what I thought, 5. So again, each individual measurement has an uncertainty of plus or minus 0.01 grams, but my final calculation has an uncertainty of 0.02 grams. So what does this mean for my histogram? Let's go back to the fact that there will always be a zero bin. The zero bin holds all of the data that could be zero. We know that my calculation could be off or plus or minus 0.02. So all the things that could be zero go from negative 0.02 grams all the way up to positive 0.02 grams. That shows us that our entire bin size is actually 0.04 grams. From negative 0.02 up to positive 0.02 takes up 0.04 grams, covers 0.04 grams. So if I'm going to make the rest of my bins, my next one up is positive 0.06 grams. My next one down is negative 0.06 grams. And then my next one up would be positive 0.1 grams, and my next one down would be negative 0.10 grams. So any losses in mass would go to the left of the zero. Any gains in mass would go to the right of the zero bin. So I just want to show you, this is what your x-axis will look like for every change in mass histogram. We have the zero bin in the middle. Everything that could be zero goes in that bin. Anything from negative 0.02 grams up to positive 0.02 grams. If we gain mass, it'll go in the bins to the right. If we lose mass, it will go in the bins to the left. Same rules apply. If a piece of data lands on the edge of a bin, for example, if I got a change in mass of 0.01 grams, then it falls right on this line and it would go into the bin to the right. Let's just watch me making a quick histogram. I got 5 pieces of data here, or 5 calculations of change in mass, and I'm going to set up a histogram, and let's just watch it happen. Setting up my x-axis and then putting my data in. Goes exactly the same way as any other histogram. So, if you have any questions, please let me know. There is a sheet up front that I would like you to go pick up. It is a set of instructions for how to make a delta mass histogram. So pick that up, make sure you can answer all of the questions, and have a great day.